Welcome again to Mto Online, your online school. We are handling a physics experiment to determine the focal length of a lens. And then the materials that we have a metal rule, we have a lens holder, we have cross wires, we have a bulb, we have a switch this side, we have dry cells here. In their dry cell holders, we have a screen here, white screen. And now, according to the procedures, we need to begin with the object distance such that we now get the image. So we have to place our screen here, and then we have a lens holder here where we shall put our convex lens. This is a convex lens and it converges light. Now, we are going to begin with u, which is the object distance, to be equal to 30. So you measure from the 0 centimeter mark and you locate where 30 is. So when I measure mine, just from here in the middle here, you should make sure that you measure distance from in the midst here of this lens here at the critical center of the lens. Now, taking this to be my 30 centimeters, I now have to locate where the image will be formed, and then I take read and record distance v. So this is my u, which is the object distance. So when I complete my switch here, the bulb gives light, and now I'm going to use these cross wires in the wire gauze screen. They are going to act as my object. Light is incident on this converging lens or convex lens, and now a convex lens, theoretically, it converges light. And now when it converges light, you're seeing them that the image is formed on the other side adjacent of the screen. So you move to and fro, you move this screen to and fro until we get a sharp image of these cross wires. So let us move. When I move it further, I see nothing. When I move it towards this lens here, I start seeing, but it is not sharp. But we say move to and fro until you get a sharp image. So I can move it further, When again I move it towards, it becomes blurred, so not clear at all. But you try to move to and fro until when you get a sharp image. So you realize that a sharp image there is formed. Now this sharp image, the distance from here to here, we are going to record it and it's going to be our V. So you get your metal rule and then you measure this distance. From here up to where the image is formed. So when I try to measure mine here, it is giving me 76 centimeters. So 26 centimeters. It is 26 centimeters, sorry. Now, this is the image distance V, and I come and record it in my table. This is 26, but since I have measured them using a meter rule, I'm going to record them to one decimal place in centimeters. So I will say 0.0. So I repeat the experiment for other values of u equals to 40, 50, 60, and 70 for accuracy of our experiment. So this time round, you now first disconnect and then you remeasure. This time round, you're going to place your screen at a distance of 40. So from here to here, it is my 40. Then I complete my my socket here the other side, and such the bulb gives light. And now I still move the screen to and fro until the sharp image of these cross wires is formed on the screen. As you're seeing, this is a sharp image. It is sharp as you're seeing it. Still, I now measure its corresponding image distance from here up to there. So this is now This is now 22.0. 22.0 centimeters. You repeat the experiment until you finish 50, 60, and 70. So when I try to measure for 50, it is placed here, the 50 is here. Then I still move my screen to and fro until I get the sharp image. My sharp image is there. I measure its corresponding image distance V from there. So I'm having 20, 20, still 0.0, and so after having our values filled there, we have V, we have U. But in our table, we said we include values of UV and U plus V. And now UV is multiplication of U times V. So we shall have the leading value, that which will, and with multiplication, we basically put our emphasis on significant figures when we look at the multiplication division rule. So when you look at U, these are three significant figures. These are also three significant figures. And so when you have three significant times three significant, our answers will be three significant. Now, when you look at that, 30.0 times 26.0, we get 780. Nothing like point anything. We don't put points. So these are already three significant. And now, when you test this, it is recorded to 0 decimal place as you are seeing. The rest of the values, you don't need to test them. Just multiply and get the values and record them to 0 decimal place as you are seeing here. So the number of decimal places is now determined by the leading value. So the leading value gave us three significant figures which were recorded to 0 decimal place, because 3 significant times 3 significant, we get 3 significant recorded to 0 decimal place. So the rest of the values will also be recorded to 0 decimal place. Then the last column is U plus V, and U plus V, it is addition, and we call it addition subtraction rule, and for it we only consider decimal place. 2 decimal place plus 2 decimal place is equal to 2 decimal place. 2 decimal places plus 3 decimal place, we record it to 2 decimal place, which is the number of decimal places. But 1 decimal place plus 1 decimal place, we can also get, or we shall also get 1 decimal place. So U was recorded to 1 decimal place plus V, which was also recorded to 1 decimal place. So even our answer will be recorded to 1 decimal place. So 1 plus 1 is equal to 1. That is according to the rules of decimal places and significant figures. So the rest of the values here, you see now my leading value here, 86, which is the largest, and it is also recorded to 0 decimal place. Then the rest of the values are equally recorded to 1 decimal place. Can write them here: 1 decimal place, 1 decimal place, 0 decimal place, then 1 decimal place. From there, we now need to graph our results. Okay. And when we graph our results, we need the scale first. So we need to get the scale. How to get the scale? Scale. And in this scale, we have two scales. We have the vertical and the horizontal. So we are, first of all, before we get the scale, we are going to get what we call indicators. So we're going to begin with vertical scale indicator. Vertical scale indicator, which is abbreviated as VSI, is given by the formula highest value minus lowest value divided by 10. Then, in the same sense, we are going to have a horizontal scale indicator. I'm going to handle them concurrently. So this is still highest minus lowest, but divided by 8. Now, we are supposed to plot a graph of UV against U plus V. That means UV, the values that are supposed to be on the vertical, and U plus V, they're supposed to be plotted on the horizontal. So, vertical scale indicator. You come in the column for UV, which are the values that are supposed to be on the vertical y-axis. The highest value is 1120 minus the smallest value, which is 780, divided by 10. But this is just an indicator. Then here, we have on the horizontal scale indicator, which is U plus V. It is highest and lowest, and it is 86.0 minus 56.0, By this time round is divided by 8. This is an indicator, not a scale. We are going to see how we get a scale. Now, let me try to get these values. We have 1120 minus 780, but divided by 10, get 34. Then 84 minus 86 divided by 8, I get 3. So here we get 34. Then here we get 3.75. This is horizontal scale indicator. This is vertical scale indicator. Now, for those of you who drive or ride, you know what an indicator means. When you are about to blanch, you always put on the indicator to show other road users that you are about to blanch. It does not mean that immediately when you put the indicator, you are branching instantly. It's not the case. It showcases that in the next point there, I am going to have a stop or I'm branching. That means our scale on the vertical, this is an indicator is 34. That means you should not use a scale below 34 because an indicator must be in front of you. The same will apply to the horizontal. It is 3.75. That should be the list. This is an indicator. But the real value for the scale should be above 3.75 because it is an indicator. Okay. Now, how do we get the real scale? Well, you're going to only recall these values. All this information, you can only find it at the Moto Online, where you have the experienced, tested and trusted practical scholars and the theory scholars. Subscribe for more videos. We are going to use these values here. I have digit 1, I have digit 2, I have 5, I have 10. Mark those values. Only 4. 1, 2, 5, 10. The rest of the values are going to come from those 4. Because if I want to plot a 4, I can use a 2 to plot a 4. Because 2 is a multiple of 4. If you want to plot a 3, 1 is a multiple of a 3. 5 is there. 6, 2 is a multiple of 6, among others. So, we are going to say, when you go up, multiply by 10. But when you move down, we are going to say divide by 10. Let us try to make a simple table here. So 1 times 10, we have 10. 2 times 10, 20. This is 50. This is 100. This is 100, 200. This is 500. And then this is 1000, among other values. Then when we go down, we shall divide by 10. 1 divided by 10, 0.1. 0.2, 0.5, and 1. I can say 1.0. Then when we again divide it by 10, 0.01, 0.02, 0.05, 0.1. One more time, 0.001, 0.002, 0.005, and 0.01. Now, this is where we are going to get our scale from. Basing on the indicator, vertical scale indicator was 34. So you come and locate where 34 is. When you look at 34, it is an indicator. It is between 20 and 50. That means 35 is around here. It is an indicator. It shows that I'm about to blanch. That means if 35 is here, I take the figure above 34. So I will take a 50 because 35 is around here. So 50 is going to be my scale. So you come here and say 2 centimeters of your graph book on the Cartesian plane. So 2 centimeters represent what? Remember, the vertical scale is UV. So it's going to represent 2 centimeters will represent 50 centimeters squared. Why centimeter squared? Because we are plotting this UV on the vertical. So we are going to say 2 centimeters represent 50 centimeters squared on paper, on graph paper, on graph paper. That is the scale. So that means we shall use interval of 2 centimeters to represent 50 centimeters squared. Then when we come on the horizontal scale, it is U plus V, which is supposed to be on the horizontal. And when we look at the indicator of horizontal scale, we've got 3.75. You come on this box here, and then you locate where 3.75 is. 3.75 or 3.8 anyway. It is around 2 and 5. Now, it is between 2 and 5. That means I can take this 5 or I can take 10, depending on what you want. You can take 5, you can take 10, an indicator. As long as I've shown you the indicator that I'm branching on the left, I can branch at the next point or even at the next further point. It's an indicator. As long as pave way for me, I'm branching on the left. So I can take a 5, I can take a 10. But when you look at U plus, you look at the values you have 56, 66, 70, 78, 86. You can anyway take a 5. So I'm going to use 5. So I'm going to say 2 centimeters represent 2 centimeters represent 5 what? It was U plus V, which is also in centimeters. So 5 centimeter on graph paper. On graph paper. Well, now we have the scale. I realize right now that you watching, tell a friend to also inform a friend that everything is on online. You now very well know how to get a scale. After getting a scale, so after getting the scale, now we come to graphing. The graph should have a heading, and in this case, the heading will be a graph of UV against U plus V. After writing the heading of your graph, you now need to organize your Cartesian plane. This is in your graph book. We need at least the graph to cover 2/3 of your graph paper. In this, however, you can simply leave only 1 centimeter from this side, and then you can leave 3 or 4 centimeters, like from 3 to 5 centimeters from down here. Then from there, you're going to draw the major axis, the x-axis and then the y-axis. After drawing those major axes, label them x-axis, y-axis. Now we already have the scale, the vertical scale and then the horizontal scale. On the vertical scale, we say 2 centimeter represent 50 centimeters squared on graph paper. So every after 2 centimeters, we are going to put there 50. Now, when I say 2 centimeters represent 50, it does not necessarily mean that I have to begin with 0 here, 50, 100 and all that. It is okay still to begin with that, but your graph again, you may realize that it may be too long. So we need 2/3 of the graph paper. However, just look at these values. The smallest value in this column, it is 780. So I can as well begin with the 700. Then after 2 centimeters, I go to 750. Still the interval is 50, 50, which is as given in the scale. So 750, 800, 850, 900, 950, up to. For you, me, my board is short here, but for you, put 1000 up to when you reach this last value, when you see that this largest value can be sufficiently accommodated. The same will now apply to the horizontal. Make markings of every after 2 centimeters, 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. Then you come in your column. The smallest value is 56 and then the largest is 86. That means if I begin with 50 here, Then the interval is 5, 5 as specified by the scale. So 50, 55, 60, 65, still the interval is 5, 5. Now from there, you put it here that u plus v, it is in centimeter, and then uv, which is in centimeter squared. The next step is plotting. However, plotting is now very simple because we've got the scale and we've already demarcated, or we've already labeled our graph categorically like that. Very smart, and you need to be in it. Now the next step, when you plotting, you need to find out how many are in one smaller division on the vertical and the horizontal respectively. When we begin with the vertical, after 2 centimeters we have 50, but there are 10 smaller divisions in 2 centimeters. So what you do, just get 50, divide by the 10 small divisions to see how many, or how much, to see how much is in one small division. So 50 divided by 10, we shall have 5. That's why you see in here 5.0 or just 5. So this 5, it is the centimeter squared in one small division. That small division is there. Remember, a centimeter has 5 small divisions. So 2 centimeters, those are 10 small divisions. So if we need to find out how much are in one small division, it is 50, which is the interval of every after 2 centimeters, divided by the 10 small divisions in 2 centimeters. So we get 5. The same will now apply to the horizontal. The interval was 5 here. The interval was 5. Oh no, the interval on the vertical was 50. So 50 divided by 10, that's when we get a 5, which is here. You put it in a small circle here. Then on the horizontal here, the interval is 5. So 5 divided by 10, it is 0.5, which is right here. Now the next is as simple as you doing anything. The rest are simple. This is how you plot. Just to get the value, you begin with the horizontal value, and then you look for the vertical value. So the horizontal values, we have uv. So this is 56. So 56, when you look at our values, 56 is nowhere to be seen. So what you do, just get your FX991 Casio calculator or any type, and then since you already have that, one small division has 0.5. So how many now small divisions can make up 56? So what you're going to do, you're just going to say 56.0 divided by one small division, which is 0.5. You will see that you will get 112. 112, those are small divisions. So you come and begin from here and you look for 112 small divisions. Of course, from here up to here, these are 10, 20, 30, 40, 50, up to. For you, your graph will have all that. So until when you reach 112 small division, you count them. They are obvious. These are 10, 20, 30, 40, 50, up to 110. Then from there, you still locate its corresponding y value, which is 710. So 710, for it, you're going to divide it with a 5. So when you divide 780 divided by 5, 780 divided by 5, you get 156. So you still count. This is 10, 20, 30, 40, 50, up to 156. Then, supposing, please, for you going to use a graph and it will come out very well. Supposing 56, supposing it might be here, around here, and then 156 is around here. You come and locate it here. Like this, you put a small dot and a small circle, like that. Put a small dot and a small circle. Put a small dot and a small circle. A small dot and a small circle. Small dot and a small circle. You plot well. After plotting well, we now need to find the slope. But we need to, one, get or to draw the line of best fit. There are around 4 rules that govern the line of best fit. One, you make sure a straight line passes through all the plotted points, which is in most cases practically impractical. Allow me to use that. It is very rare to find that all the points plotted are in a straight line. Some may be a little bit on the veranda of the straight line. So that is one. So when I look at my points, for example, if I'm using these points, 1, 2, 3, they are in a straight line, but this and that, they are away in the line. So I leave out that. 2, the next rule is that pass through most of the plotted points and leave equal number of points on either sides. So what we do, you pass through these 3 and then you leave 2, 2, 3, 3, 1, 1 or 1, 2. One side should be equal to the other. The points that are not passed through should be equal on both left and right, or should be exceeding by 1 or 2. Then the last one is pass through none of the points. If you realize that when you pass through most of them, it is still not making sense, then pass through none of the points, as long as now your line of best fit divides the points into equal numbers. You leave the other side 5, then the other side also you leave 5, and you pass through none. It's still a good or a fantastic line of best fit. So in this, my 3 points are in a straight line. Use a long ruler and you join them unlimitedly like that. You realize that I've passed through 3 points and then I have left one this side and one up here. Then from there, you simply now make your slope. Slope. You come and close this last point. This last point is right here. You come and draw a line like that. Make sure you close this last point. You draw a line from here to come and meet the horizontal axis, or the u plus v centimeter axis. Then you also come and close this first point here. You're going to close it here to be inside this triangle. We want to form a triangle. This is the slope we are talking about. We've called it f. Now, I realize that this line that I've used for closing, it is cutting the line of best fit at a certain point. So this point of contact, or this point of intersection, you still draw a line from x-axis to meet it. So you draw a line like that. Then don't forget to still close this point up here. So you use your ruler and you close this point here. So this point here, this was our y-axis. Now from there, you're now going to label them. You're going to call this x1, going to call this x2. You call this y1, you call this y2. y1 because they are on the y-axis. Now from there is finding the slope. And according to the procedure we had, it's that when you find the slope, then the slope will be equivalent to the focal length of the convex lens that we are determining. So you're going to say slope. Slope is the same as gradient. So slope f is given by change in y over change in x. And now a change in y is y2 minus y1 over x2 minus x1. Or you can say y1 minus y2 over x1 minus x2. You get the same answer. So you just come and summarize. You get the values here for x1 and the value for x2. Then y1 and y2 respectively. You come and punch in here. Then after you get f. The value of f, or the slope, will be equal to the focal length of the lens. When you get an answer which is in the range of 8.0 to 12.0, conclude and advise them that the new labeled lens P will replace, or can ably replace, the projector, the broken one of the projector, because it is in the range. What if I get my focal length which is out of this range from 8 to 12? Because the specifications of the projector showed that it can only use a lens of focal length 8 to 12. So if for you you get 15 point something, this is greater power, and so advise them not to tamper with this lens. Let them go back and buy new lens. Thank you for watching.